Welcome to one and all. Myself, Dr. V. Sharan Raj. So let us get into this third session, metallurgy of welded joints, metal crystal structure. So we had seen various types of crystal structures and what do you mean by crystal structures, atoms and all. Let us see what is crystal structure defects or crystal imperfection. All the different types of crystal structures with their arrangement of an atom are true only under ideal condition. What is ideal condition? Ideal means the material should be, the crystal structure of metal should be perfectly tetrahedral. Means this ideal condition, all the metal crystal structures will not satisfy this. That means that all real crystal structures generally have imperfections among their unit cell. What is imperfection? Imperfection is nothing but a malfunction or a defect in a material. What happens if there is a defect in a material? So when the material is subjected to load, if there is any defect, so the metal cannot withstand the recommended load and the failure will occur. So in order to have the failure free defect material, so we have to have the ideal material. So here this means that all real crystals, it is not ideal crystals today, all the crystal structure are real, they have some imperfection among them. Without imperfection, I think it's very difficult to find a metal in the present situation. So what are the different types of crystal imperfection? There are 4 types in that. One is point imperfections, means point defect. So the defect looks like a only at particular point, not everywhere, at one particular point, at one particular site. See, these type of defect will occur. Line imperfection. So what is this line imperfection? This imperfection occurs between the 2 different grain boundaries. So along the grain boundaries, the line imperfections will occur. Surface imperfections. Third one is surface imperfections. What are surface imperfections? So these imperfections, those will appear on the surfaces of the material. It may be grain boundaries, tilt boundaries, twin boundaries, stacking. So by the boundaries, you can visualize and say what type of imperfection it is. Next is volume imperfections. So volume imperfections may be during the manufacturing process, like blowhole. What are the different types of defects that we occur during manufacturing process? The common problems will appear here, such as blowholes, cracks, foreign inclusions, and so on. So let us see what is point imperfection. So in your syllabus, you are supposed to mention any one kind of, especially point imperfections. You have to explain all the vacancy, interstitial atom and substitutional atom. All other things are just different types of crystal structure you are going to explain in this. So let us see what are the different types of crystal structure in defects in that. So first one, in a point defect, the first defect is a vacancy defect. You can see here in the given sketch there is an arrangement of atoms. So you can see the arrangement of perfectly symmetric. Symmetric means number of atoms, rows and columns are almost same, and you can here also you can see so number of atoms. So what does this kind of defect vacancy means? So vacancy, as the name indicates, there is some vacant in the atom positions. So here vacancy refers to an atomic site. It is an atomic site from where atom is missing. Can you see here? There is a atom is missing. This atom missing will create a vacancy so that some other imperfect crystal metal can come and sit inside and cause a defect. This vacancy is there. Suppose if you measure any hardness along these points, the hardness will be high. If you measure the hardness at this point, because the atom is missing, the hardness will be less. So this area will be a weaker area. This is a kind of a defect. We see vacancy is a kind of a atom missing is a kind of a defect. So it refers to atomic site where the atom is missing. So this may be due to imperfect packing during the original crystallization. Why this type of defects are caused? It is kind of a defect caused during manufacturing operations. So this is caused due to the manufacturing defect. Okay. So or due to thermal vibration of atom. What is thermal vibration of atom? and the metal is subject to heat. When the vibration occurs, the atom may shift from one particular atomic state to the another atomic state. Due to this, what happens? The vacancy will occur. So what is vacancy? It refers to an atomic site where the atom is missing. So this may be due to imperfect packing during original crystallization or from thermal vibration of an atom. So vacancy is a kind of a point defect. So at one particular point the atom is missing. So next let's see what is known as interstitial atom. So the last vacancy was the atom was missing. There was a vacant position there. But here what is going to happen here? Here in the sketch you can see, dear students, there is a parent atom. So these are all parent atom. So can you see the color codification here? So the parent atom is gray in color, whereas the interstitial atom is known as blue in color. For example, carbon in iron. So this is iron, gray is iron, blue is a carbon. So carbon in iron. Why we will call in iron? Carbon in iron means carbon percentage is less, iron percentage is more. That is why. So carbon in iron is a very good example. What do you mean interstitial? Interstitial means it is a small size foreign atom. What is foreign atom? Foreign is a kind of a extra outside material, outside atom. Foreign means outside. So here in this, so parent atom material, if it get inside and if it comes, it is not foreign atom. Only thing is outside, some other, for example, carbon atom. So the small size foreign atom that occupies the space between the atoms of a crystal structure without dislocating any parent atom. If you see here, the atom's arrangement is perfect. It's very difficult to identify the kind of a defect. But the problem is but it is not dislocating. The atom has come and it has occupied the space within the different material. But what is the problem here? It is not dislocating any parent atom. That is also why it is very difficult to identify this type of defect. We have to put it in a traveling microscope and check what is the crystal structure in this. So these interstitial atoms, when it get inside the any vacant position, it will not dislocate any kind of a material. So identification of this type of defects is very essential. And this is a kind of a point defect. Only at that point it is coming and replacing. So carbon is replacing only at that particular iron, not everywhere. So and even if you see that the structure is not varied, so this is what is this. So one is vacancy is missing, another one is interstitial means addition of one atom to the vacant position. This is known as interstitial atom. So in this next you can see what is known as substitutional atom. So this is kind of a point defect. What is substitutional atom in this? Substitutional atom means, so we will have a copper atoms. So entire set of copper atoms, there will be one atom called zinc atom. So this zinc atom substitutes a copper atom. Zinc atom is going to fit to the position of copper atoms. So zinc is an impurity, copper is a pure. Copper is a pure atom. Zinc is an impurity, I can call it as. So impurity is created when the foreign atom, zinc atom, substitutes a parent atom, copper, along in the lattice structure. So you can see here. So it is going to get it into the zinc atom. So if you see copper and zinc wise, so the strength may be different. So that the variation in strength is accounted. So impurity is created by the zinc atom, which substitutes a parent copper atom in a space lattice, in a work volume. Example, zinc atom replaces the copper atom. Zinc atom is going to replace the copper atom in this case. So next is, you can see what is known as atomic structure. In the last class we had explained various types of what do you mean by atoms and all. Let us see what is atomic structure. Once again, it's a kind of a similar topic over here, so you can brush up all those things. What is atomic structure? Atomic structure means it consists of electrons, protons and neutrons. Electrons, protons and neutrons. So as I said, electrons are negatively charged. Protons is here in this case is red in color, they are positively charged. Neutrons here in this case is blue color, that is no charge. So combined the innermost orbit, whatever the protons and neutrons is there, those are known as nucleus, the central part of a atom is known as nucleus. The outermost is called electrons. So let us come to the metals are the substance composed of separate atoms. This is a one atom. There are number of atoms. As I said, like zinc atom is there, copper atoms is there, number of atoms are there. So here metals are the substance composed of separate atoms. Any atom, no matter what the material have, the same basic type of structure. It means the atom generally will have the same basic structure. The structure doesn't change irrespective of the material changes. It may be composed of separate number of atoms and separate number of materials, but here it doesn't change the basic type of structure. So atom consists of, as I said, nucleus at the center. It will have positively charged protons, negatively charged electrons, neutrally charged neutrons. So this is some kind of things. Here the sharing of electrons takes place at the outermost orbit. Next, what is atomic structure? Atomic structure means nucleus is composed of the mass of the atom surrounding the nucleus in a orbit or a shell. As I said, nucleus is composed of mass of atom. So it will have number of shells. The outermost, when it goes on outermost increasing, so it called as this. So there is a formula for having number of electrons. There is a restriction for formula saying that the maximum number of electrons that exists in any orbit shell is represented by 2n square. What is n? Capital N is the shell, this shell, number of shells. So for example, if it is a first orbit, n is equal to 1. If it is a second orbit, n is equal to 2. If it is a third orbit, n is equal to 3. So it depends, as I said, there are number of orbits in that. So the outermost orbit will have a electrons. So according to the formula, if n is equal to 1, 2n square is what? So 2 into 1 square is equal to 2 electrons. So that orbit, the first orbit will have eligible maximum number should be 2 electrons only. It cannot exit more than that. In a second shell, it is 2 into 2 square. 4 into 8, it is 4 into 2, it is 8 electrons. Means it should have only 8 maximum. It can have less than that, but minimum criteria is not there. Your maximum is very important. Maximum 8. If it exists more, then it causes unbalance. So next, characteristics of all metals. In this, there are always 3 electrons in the outermost shell. Means there will be, if you observe the characteristics of all the elements, minimum 3 atoms will be outside the electrical structure. That means outer shell will not be completely filled with electrons, no matter the shell number. Means here minimum 3 will be there. Maximum numbers is, you can't find such maximum numbers at the outermost shell. The electron releases readily from the atomic structure, and they are used to join one atom to another atom, and for the bonding of electrons from the metal. How the atoms are bonded together? By intermolecular forces. As I said, the metals are bonded, atoms are bonded together by an intermolecular forces. Okay, so what does it say? So the electrons releases readily, the outermost orbit electrons will release readily, so they are going to form the bonding of electrons for the metal. These electrons, the released electrons, are known as valence electrons. These released electrons are known as valence electrons. So dear students, so we saw what are the different types of defects. So in that defects, we saw point defect, we saw line defects, and we saw what are the surface defects and volumetric defects. In that we have detailed discussed about a point defect. So let us see the model questions. So multiple choice questions, let us see. So the strength of the material dash with the presence of crystal structure defect. Means with the presence of crystal structure, what is the effect of strength of materials? Whether it decrease, increase, equal, as no impact. What happens if there is a defect? So if there is a defect, so the strength decreases. Vacancy is a kind of dash defect. It is a kind of a point defect, line defect, surface defect, or a volume defect. What kind of defect it is? Vacancy is a kind of point defect. So as I said, it is a point defect. Only at that particular point the atom is missing. Interstitial means it is a kind of dash defect. So interstitial atom means it is a kind of a surface defect, line defect, point defect, or volume defect. Which kind of defect it is? It is again a point defect. So next, substitutional atom is a kind of dash defect. Again, it is surface, point, line, volume. Which kind of defect it is? Only at that point the defect, and only at that point the defect occurs. Hence, it is called point defect. Edge dislocation is a kind of dash defect. Fifth one, a point, line, surface, or volume. Edge dislocation, it is a kind of line defect. Screw dislocation. Screw dislocation is a kind of dash defect. So screw dislocation is a kind of dash defect. So as I said, it is a kind of surface, volume, point, or line defect. What kind of defect it is? It is a line defect. Seventh question. Grain boundaries is a kind of dash defect. It is a surface defect, point defect, line defect, or a volume defect. What kind of defect it is? Surface defect. So the grain boundaries are observed in a kind of surface defect. The electrons released readily from the atomic structure is known as. Electrons released are known as what? Volume, line, surface, or valence. What kind of defect it is? Valence electrons is known as valence electrons. The maximum number of electrons that exist in any outermost shell is, as I said, formula 2n square, 2n cube, 2n to the power of 4, 2n. Which is the formula which you use? 2n square. If it is 1, it is 2. If it is n is equal to 2, it is 8. Similarly, if you go on multiplying, we can calculate what is the maximum number of electrons. It is not minimum, it is a maximum number. The process of joining one atom to another atom, what is that process called? If you atoms are held together by intermolecular force, what are the kinds of? Is lapping, soldering, bonding, and brazing. What is this kind of defects is called? So this kind of defects is known as what? This type of joining process of one atom to the another atom is known as bonding process. So dear students, we saw what are the different types of defects we found. In general, I would like to say any metal whichever is taken for a production purpose, the incoming material will be subjected for quality tests. So in industries, if you go, why we are speaking about this type of defects means where it is useful for you for industries means you may be appointed as a quality inspector or quality supervisor or so on. Tomorrow, first, if you are a planning engineer, first incoming will be the material. First material, you are going to test it. Once you test it, you are going to identify what kind of defect it is. Whether this defect is which cannot be, this defect can be repaired, or this defect has to be rejected. We have to identify that. So when the incoming material, when you test for a quality, you will identify what is a defect and you will analyze which kind of defect it is and how to eliminate this type of defects. So if you eliminate this type of defects, some defects can be eliminated at manufacturing process, some defects cannot be eliminated, but it can be repaired. But you have to work out which kind of defects we are going to identify. So very simple, you saw what I mean by defects. So the defect generally, it reduces the strength of the material. So any kind of defect you take, it may be a point defect, line defect, surface defect, volume defect, but the purpose of the defect is to reduce the strength of a material. So industries target are used to give the defect free components, zero defect. They are working on zero defect components. So not even single screw should be rejected. So they work for such a quality, because the quality, defective quality metals, when it enters to the market in a products, so it cannot withstand the durability of the component. It does not satisfy the life cycle management of the component. So in order to satisfy all those things, so you have to identify what are the defects. So it starts from the material, you are going to identify the defects and say what solution we can give. Dear students, thanks for your patience listening, and I will end this session of the session 3. Thank you.